Every sunrise you have ever seen is already 8 minutes old. The light hitting your eyes right now left the sun before you even thought about looking up. You have never seen the sun as it is. Not once in your life. And that's just the beginning of what the solar system poster got wrong. That poster you grew up with, the one with the neat row of planets, everything color-coded and labeled, was never a map. It was a compression trick. It crushed the one thing that actually defines the solar system, distance, until everything looked close enough to touch. And your brain learned the wrong lesson. It decided space was full, planets were nearby, and the solar system was a place you could picture. It isn't. By the end of this video, the solar system won't feel like a diagram anymore. It'll feel like what it actually is. Let's start with the light. Because light is the fastest thing in the universe. Nothing comes close. And even light struggles with the solar system. When sunlight leaves the surface of the sun, it crosses 150 million kilometers before it reaches your eyes. That crossing takes 8 minutes. 8 minutes for the fastest thing in existence. Now go outward. Light reaches Jupiter after 43 minutes. Out near Neptune, it takes over 4 hours. The solar system is not a real-time place. It is a delayed world. Everything you see is the past. The further out you look, the further back in time you're seeing. And that delay doesn't just affect what you see. It affects everything we do out there. When Mission Control sends a command to a spacecraft near the outer planets, that signal travels at the speed of light. And it still takes hours to arrive. Then engineers wait hours again for the reply. Every conversation with a machine in deep space is a conversation with the past. Imagine trying to drive a car where every touch of the steering wheel takes 40 minutes to have an effect. That is what it actually feels like to operate a probe near Uranus or Neptune. You don't control what's happening. You anticipate what will happen. And then you wait to find out if you were right. This is the reality Voyager 1 forced us to confront. Launched in 1977, Voyager has been moving non-stop for nearly 50 years. It is now beyond the heliopause, the boundary where the sun's solar wind ends and interstellar space begins. Voyager crossed that line in 2012. And the signals it sends back home, traveling at the speed of light, still take over 20 hours to reach us. Nearly 50 years of travel, over 20 hours for a light-speed signal. And Voyager has barely left. That is the solar system. Now here's where the poster really lied to you. Look at any solar system diagram and you see a family, 8 planets, roughly evenly spaced, orbiting together. That picture hides something that changes everything. The Sun contains 99.8% of all the mass in the solar system. Not most of it. Not the majority. 99.8%. Every planet, every moon, every asteroid, every comet, every spacecraft ever launched, all of it combined, is the remaining 0.2%. The solar system isn't a family of planets orbiting a star. It is a star, with a thin scattering of dust around it. And we live in the dust. Jupiter is the largest piece of that dust, more massive than every other planet combined. And even Jupiter represents less than 0.1% of the solar system's total mass. Saturn with its rings, Mars, Earth, the entire asteroid belt. Invisible on this scale. Not a family, a monarchy. One overwhelming gravitational empire, and everything else is debris. Speaking of that debris, Hollywood sold you a lie about the asteroid belt. Every space movie shows it the same way. A dense river of tumbling boulders, pilots weaving between rocks at full speed, constant collisions, total chaos. The real asteroid belt is the opposite. It is vast, and it is nearly empty. If you flew a spacecraft through the actual asteroid belt in a straight line, the odds of hitting anything are extraordinarily low. The typical distance between objects runs into the hundreds of thousands of kilometers, often more. The dominant experience wouldn't be chaos. It would be silence. The danger isn't crowding. The danger is invisibility. Objects so dark, so small, so far apart that detecting them requires precision instruments. The solar system isn't just empty between planets. Even its most crowded region is almost entirely nothing. Now here's something worth sitting with for a moment. On a clear night, with a basic beginner telescope, or even a good pair of binoculars, you can see Jupiter with your own eyes. And if conditions are right, you can spot the 4 largest moons Galileo first observed in 1610. Tiny dots lined up beside a slightly larger dot. But knowing what you now know, knowing that the light you're seeing left Jupiter 43 minutes before it reached your eyes, it hits differently. The planet you're looking at isn't the planet as it is. It's the planet as it was 43 minutes ago, across hundreds of millions of kilometers of empty space. If you've been thinking about getting a telescope to start exploring, I've linked what I actually recommend for beginners in the description. Nothing expensive, nothing complicated, just what works. And now we reach the part almost no poster ever shows, because it doesn't fit on the page. People imagine the edge of the solar system as a final planet, a clear boundary, a line you could point at on a map. The solar system doesn't end that way. It ends like a fog. Beyond Neptune lies the Kuiper Belt, not a clean ring, but a vast diffuse zone of icy bodies stretching across distances so enormous that the concept of a single edge starts to dissolve. Pluto sits inside it. But Pluto is not the end. Pluto is a messenger from a region that continues far beyond it. Farther still is the heliopause, the boundary where the sun's solar wind runs out of energy and interstellar space begins. Voyager 1 crossed it in 2012, Voyager 2 in 2018. Our machines have left the sun's breath. But even that isn't the true edge, because the sun's gravity reaches much further than its wind. Scientists believe there may be an enormous shell of icy bodies surrounding the entire solar system at a distance so extreme that even our fastest probes traveling for decades would need thousands of years to approach it. If that structure exists, and we have good reasons to think it does, then the solar system is not a flat disk of planets. It is a deep gravitational ocean with an invisible shoreline we have never seen and may never reach. The last planet? The edge of the solar wind? The reach of gravity? The solar system refuses to answer. So here is what the poster was hiding. Not the planets, the emptiness between them. The solar system is mostly nothing, a void with a few islands of matter separated by distances that light itself takes hours to cross, governed by a single overwhelming gravitational empire with boundaries so distant that our fastest machines will spend thousands of years just approaching them. And this, all of this, is just our immediate neighborhood. The closest star to our sun is so far away that Voyager, moving nonstop for nearly 50 years, would need another 70,000 years to reach it. Not 70,000 miles. 70,000 years. What exists in that distance, and what we've actually managed to detect inside it, is the next conversation. And it is stranger than anything we've covered today.